Greetings and welcome back. We're actually going to take a look at a new chapter. Today we're looking at Chapter 4, Lesson 1, Operations with Polynomials, Part 1. This is a rather large lesson, so I did split it into 2 separate days. Our learning targets that we're mainly going to focus on for today in this video are I am learning to multiply, divide, and simplify monomials and expressions involving powers. And then in the next video, we'll take a look at that second learning target. So let's scroll down. To simplify an expression containing powers means to rewrite the expression without parentheses or negative exponents. So no parentheses and no negative exponents. We actually have several different properties of exponents that'll help us do this. The first property that we're going to discuss today is the product of powers. This only occurs when we have the same base. So bases are the same. And if you need a little quick reminder, this is called a base. That is called an exponent. So when our bases are the same, we end up adding the exponents. So when it says multiply these two bases, in reality, we're just going to add the exponents. So here we have an example, 3 squared times 3 to the 4th. Our bases are the same, so 2 plus 4 is 6. Same with p to the 2nd times p to the 9th. We're multiplying, our bases are the same, so we add 2 plus 9 for p to the 11th. Next, we have quotient of powers. Once again, our bases are the same, x and x, so bases are the same. But when we're dividing, in actuality, we end up subtracting our exponents. So here we have 9 to the 5th divided by 9 squared. 5 minus 2 gets us 3. Next example, we have the same base, b to the 6th divided by b to the 4th. 6 minus 4 is b squared. All right, next let's talk about negative exponents. Here's the thing, you are not allowed to have negative exponents. No negative exponents, so really pay attention to this one. Anytime you have a negative exponent, in reality, you're going to switch its location. So if your negative exponent is up top, you rewrite it as 1 over your base of the exponent. If your negative exponent is in the denominator, you just rewrite it as a whole. So here we have 3 to the negative 5th. Because the negative 5th is up top, we just rewrite it as 1 over 3 to the 5th. And if it's already in the bottom, we just rewrite it as b to the 7th. Power of a power, that is the easy one. It says if you have a power to a power, here we have a and b, we end up multiplying these exponents. This happens when you have parentheses. So you multiply your exponents. So here we have 3 cubed quantity squared. 3 times 2 is 6. D squared to the 4th, 2 times 4 is 8. Now we have what we call power of a product. And this says when you're multiplying 2 variables inside parentheses, you're actually going to distribute that exponent to each of your bases. So it becomes x to the a, y to the a. So here we have 2k to the 4th. That 4 is going to go to both the k and the 2. So we get 2 to the 4th, k to the 4th. And 2 to the 4th actually simplifies to 16. Now we have power of a quotient. Once again, it's in parentheses. That power is going to get distributed to everything. So a goes to x and a goes to y. And if it's negative, you actually just end up flipping the fraction inside your parentheses, and once again distributing that exponent to both the numerator and the denominator. So here we have quantity x divided by y, all to the second power. So we distribute that 2 to both the x and the y, and we get x squared over y squared. And then Mrs. Younger's absolute favorite rule of all time is the 0 power rule. And this says anything, no matter what on the planet it is, if anything is raised to the power 0, the answer is always 1. Always, always, always 1. All right, now we're going to recall that a monomial meaning one term, which is where that prefix mono comes from, can be a number, a variable, or an expression that is the product of one or more variables with non-negative integers. Product meaning I can be multiplying all these things as long as I don't have any adding, subtracting going on. So when can we simplify monomials? A monomial expression is in simplified form when and only when there are no power of powers, each base appears only once, all fractions are in simplest form, and there are no negative exponents. So let's take a look at some examples. And we're going to start out hairy. So we have 2a to the negative 2 times 3a cubed b squared times c to the negative 2. First thing I want you to notice is, do we have any powers to a power, anything outside of the parentheses? In this case, I have nothing occurring in these spots right here, which means I can actually take away all of my parentheses. So I'm going to rewrite this as 2a to the negative 2 times 3a cubed b squared times c to the negative 2. The first thing I want to do is simplify everything I can. I want to put a's with a's, b's with b's, c's with c's, and coefficients with coefficients. So here we have a coefficient of 2 and 3. So what is 2 times 3? We have 6. All right, now let's do a's with a's. I have a to the negative 2 times a cubed. All right, well, when we look at our monomial properties, that is multiplying two monomials with the same base. So we add negative 2 plus 3. All right, let's look. Let's do our b's. I only have one set of b's, so b squared. And then I have only one set of c's, which makes it c to the negative 2. All right, let's keep simplifying this. That coefficient comes down, it stays 6. But now, what is negative 2 plus 3? The answer, 1. So I only have one a left. There was nothing to simplify that b with. But that c to the negative 2, we don't want a negative exponent. So we move it to our denominator, c squared. We just put it in the bottom, and when we do that, it becomes a positive. And that, my friends, is our answer. All right, let's take a look at this problem right over here. There are two ways we can do this. We can do this the long way and the short way. First, let's do it the long way. It says I have q squared r to the 4th over q7 r to the 3rd. So we'll go long way right here. in which we actually expand all of our variables out. So we have 1q, 2q's because it's q squared, and r to the fourth, so 4 r's. 1, 2, 3, 4. In our denominator, we have 7 q's. 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, 7, and 3 r's. 1, 2, 3. Now let's just go ahead and cross out what we can. We cross out pairs. So 1 pair, 2 pairs. So that gets rid of our q's. 1 pair of r's, 2 pair of r's, 3 pair of r's. And what do we have left? We have 1 r left up top and 5 q's on the bottom. That is one way we can do this. Now, the alternative way, the short way, the way that Mrs. Younger loves to do it, right? We'll say alternative way. Is we take a look. Where is my largest q? Well, my largest q is in the bottom. So I'm going to put q in the bottom. Where's my largest r? Up top. So now I'm going to take a look. I have q squared and q to the 7th. I want to do large minus small. So in this case, 7 minus 2 is 5. And so I put a 5 there. Now I have r to the 4th over r cubed. Large minus small, 4 minus 3 is 1. Boom. Done. Now, one last way that Mrs. Younger will show you is if we put everything up top. So, how do we rewrite an exponent to get it from the denominator to the numerator? Well, we make it a negative. So we already have a q squared, but now we have q to the negative 7. We already have an r4, but we're going to move the r3 up and we're going to make it a negative. So now 2 minus 7 is negative 5. So I have q to the negative 5. And then we have 4 minus 3, which is 1, so 1r. And then once again, we don't want any negative exponents, so we just rewrite this as r over q to the 5th. Now, once again, Mrs. Younger's favorite way is right over here. So just recall that. All right, next example. We have a power to a power, and that power is going to be distributed to every single term inside the parentheses. Every single term. So the 3 goes to the negative 2, and it goes to the 4, and it goes to the b squared. So when we rewrite this, we get negative 2 cubed, a to the 4 times 3 over b squared times 3. All right, so in your calculators, negative 2 cubed is negative 8. 4 times 3 is 12 over b to the 6th. And the key here was just to make sure we distribute that 3 to every single term. All right, let's go on to our next example. All right, I have no powers to the powers. That means I can rewrite everything on one line. When I do that, we have 2x to the negative 3 y cubed times negative 7 x to the 5th y to the negative 6. So first things first, let's go ahead and do our coefficients. 2 times negative 7 gets us negative 14. Let's do our x's. I have negative 3 and 5. So because we're multiplying with the same base, we end up adding, so -3 plus 5. And then we have our y's. Y cubed, y to the -6th. Once again, they both have bases of y. So we're going to add 3 plus -6. So now -14 x to the whatever -3 plus 5 is, and in this case it's 2, y to the 3 minus 6, which is -3. Are we done with this problem yet? We're not, and that is because we still have that negative exponent. We need to get rid of the negative exponent. And so we take this y cubed and we rewrite it and put it in our denominator. So -14x squared is actually going to be our numerator, while that y cubed comes down over here and becomes positive when we put it in that denominator. So it's very important that when we're moving things between our numerator and our denominator, we're actually changing its sign. If it's negative, it becomes positive. Positive becomes negative. But that only refers to the exponent, not the coefficient. All right. Next example. Let's do our coefficients first. 15 divided by -3. Well, in our calculator, that gives us 5. All right, we have c to the 5th over c squared. Where is our largest c? Is it in my numerator or my denominator? Well, c to the 5th is larger than c squared, so it is in our numerator. And now we just subtract. 5 minus 2 is 3. Now we have d cubed and d to the 7th. Where is our largest d? It is in the denominator, so we're going to put it in the denominator. And then we just subtract 3 minus 7. Oh, not 3 minus 7, large minus small. 7 minus 3, which is 4. And there we have our answer. All right, going on to our next example. We have a power outside parentheses, which means we need to distribute that power to everything inside. -3, +4. When that happens, we get a to -3 over 4 to -3. Well, these both have negative exponents, which means they both have to switch positions. So I'm going to make a note. We're going to switch because they're both negatives. And now we have 4 cubed over a cubed, which is 64 over a cubed. Remember, we are not allowed to have negative exponents. All right, and then our last example for this set of notes, we have a power to a power, which means we have to distribute that 5 to every single term. We distribute it to the 2, to the 3, and to the -2. So when we rewrite this, we get -2 to the +5 exponent, x cubed times 5, y squared times 5. So now, in our calculator, we're first going to do -2 to the 5th, which gets us -32. Next, we're going to do 3 times 5, which gets us that 15. And lastly, we're going to go 2 times 5, which gets us 10. And there, my friends, is the last answer of this set of notes. If you have any questions, please feel free to email me. You do have an assignment. Make sure you're completing it.